Here we go. Pause as you need to. I'm going to take the first few seconds and just scroll through the answers so you can check and see which ones you need to actually watch first. Okay, I'm going to take a minute to go through and actually discuss how I did each problem. So fast forward to whichever ones you need to. There's no need to watch this entire video because it will be long, even though you're welcome to do so. All right, questions 1 and 2, it says to write them in standard form. So I'm going to be writing my work in blue. Standard form is just the exponents are decreasing, so all you're doing is rearranging each of the terms so that they're in decreasing order, which is what I've done. Degree comes from the highest exponent. The leading coefficient comes from the very first number, and I actually made a mistake here. That leading coefficient should be -3. All right, question 2, same idea. Highest exponent goes first, so I'm just counting down, 7, 5, 4. The degree is 7 from the highest exponent. The leading coefficient is 4 from the coefficient on the first term. Questions 3 and 4, sketch a rough graph. Okay, I'm going to spend a minute here. Some things that you want to note. This is a different way than I've explained it before, so I'm going to see if this makes any more sense to you. When I look at this, I see that this is odd, and the degree tells me, so it's got an odd degree, that tells me what my end behavior is. So odd is going to have opposite end behavior. It's odd because I've got x squared, so that's 1, 2, 3 x's total. I know that on the right side, this right here is the end behavior for the right side. So I know on the right side, it's going to go down. That's where, if you follow, that's where I'm getting this down arrow here on the right. All right, the last part is the roots, which I think you all are pretty good at noticing. It's the opposite of what's inside of there. So I have a root at 5 and a root at -4. So I went ahead and marked 5 and -4. And I know that anytime I've got squared, that's a double root, which remember, that's going to bounce. Notice how at 5, it's not going through the x-axis. It's touching the x-axis and going right back down. Okay, let me talk. It's the same idea for question 4. So question 4, the first thing we're going to do is talk about the degree. Since the degree here is even, and I know that because there are 1, 2, 3, 4 x's. There are 4 x's, so I've got an even degree. That means my end behavior is going to be the same. It's either up and up or down and down. Then I look at the front to determine if that's a positive or negative number. I don't see any negative signs, so since it's positive, that means on the right side, it's going to go up, which means the only possible end behavior is up, up. That's where I'm getting these two from right here. The last piece is to think about our roots. Remember, if x is by itself, from the very beginning, if x is by itself, then that's just 0. My other roots here are -3, -4, and 2. I'm just pulling from each parenthesis. The last part, so I'm going to plot those. The last part is figuring out how to connect all of that. And because there are no double roots, see, there are no exponents up here at the top. Because there's no exponents, it's not going to bounce anywhere, which means it has to go through all of these points. And once I do that, I can just connect and draw. So it should look something like a W. Okay, question 5 and 6. 5 and 6 is going the other direction. They're asking me to write an equation. So the first thing I would do, some of you actually may think this is easier. The first thing I'm going to do is find my roots. This was -1, so I did x plus 1. Remember, it's opposite. This one's at 4, so I did x minus 4. That's where those two things are coming from. And then the only other thing I have to really consider is the end behavior. Since these are both going up, I'm going to have a positive whatever out there, so I'm not going to put a negative sign. And then the last thing you should think about is it bouncing anywhere? So are either of these roots a spot where it's touching and turning back around? And that's not true. It's going through both of them, so that's why I didn't need to put any additional exponents up there. Question 6 is very similar. So the first thing I'm going to do is mark my roots. All right, this root right here is -1. That gives me the x plus 1. -2 gives me, positive 2 gives me x minus 2. Remember, 0 looks like an x. And the reason here, I'll erase my markings so you can see a little bit better. The reason that this is x squared is because on 0, it's going to bounce. So because that's happening and it's not going through 0, it's got to be squared. The last piece of my equation I think about, because both of these are going down, specifically because the one on the right side is going down, I need to have a negative number out here at the front, so I just put a negative sign. Okay, down here at the bottom, if you were to have made any mistakes here, don't make this any harder than it has to be. Here, there's a plus sign, so really it's just ones that are distributing. Ones don't change anything. So really you're just copying down what you see right there. There's nothing's changing, no signs or anything. I'm just dropping the parentheses. 5x to the... All right, and then the last thing I did was I just combined like terms. My x to the 4th gave me 8x to the 4th. To the 3rd gave me 8x to the 3rd. And then if I combine these last ones, I got 3x. Okay, on this side, same idea, except right here, a -1 is distributing. So the first set of parentheses stays the same, but the second set, all the signs are going to change. So -1p plus 1 plus 2p to the 3rd. If you need to pause for a second, all of this is coming from me distributing this -1. Okay, now I'm just going to combine like terms again, and it helps me to go in order. So nothing goes with the 5p to the 4th, so I just copied it down. 2p to the 3rd plus 2p to the 3rd is 4p to the 3rd. Nothing goes with that -1p, and then -1 and +1 goes together to give me -1 right there. All right, 9 and 10 are the same way. They're just a little bit longer. So I'm actually going to pause, and I'm just going to show you my distributive and then what I'm combining instead of talking through this whole section. Okay, so when I distributed this negative out here at the end, what you see written in green is what I got from that distributive property, just simplifying. Check your signs. So if you made a mistake, that's probably the first place you would have made a mistake. And then I'm just going to combine. So I've got x to the 4th, -8x to the 4th. That's where I'm getting this -4. Some of you may have luck crossing those out to see what we've got left. Nothing to the 3rd power, so my x squareds. Combine all those, and you should get 6x squared. X's, I've got -5, -4, and -7, and that's where I'm getting -16. All right, same thing on number 10. Again, check your signs to see if you've distributed everything correctly. Now we're just going to combine. I've got -4x to the 4th, -8, I said x in, -8n to the 4th. That's where I'm getting my -12. I have 6n, -4n, -4n. That's where I'm getting my -2. I have a +4, +4, +5. That's where I'm getting my 13. And if I haven't already said it, the reason that you stop there is just because there's nothing else left to combine at this point, right? Everything has different exponents with different variables with different exponents. This whole set down here, 11 through 15, is a little bit different. It's all multiplication. You know that because there's no plus or minus signs. So real quickly, I'm just going to show you my work on each one of these, show you my 2 distributive or however many distributive problems there are. If you make mistakes in here, you're making small errors most likely. So just run through whatever you need to on each problem. All right, in green and blue, I'm trying to color code so you can see where I'm getting stuff. These are my 2 distributive answers. And then if we go back and look, some things that we can combine together are these x, y's in the middle. Right here, you may have written yx. That's the same thing as x, y. And also note, this is like a 1. That's where I'm getting 25 in the answer. So those are the only things that combine, which is going to give me my final answer right here. I'm going to show you the same work for number 12. Before I do that, you may not notice that this is multiplication, but squared means that that's happening twice. So really, this problem is telling me to do 5x plus 4y times 5x plus 4y. All right, I'm going to pause and do my distributive property. And here's what I have. Those are my 2 different distributive properties. Again, when I do this right here, I write that xy instead of yx, just so that everything's in the correct order. The only thing left to do is combine like terms, and only these middle terms combine to give me 40. That's how I'm getting my final answer right here. Just like on the others, on number 13, what I'm going to do is pause and do the distributive property so you can check your signs and multiplication. Okay, there's my distributive property. Only thing I have left to do, as with the others, is to combine like terms. So I'm looking for terms that have the exact same exponents on the same variables. For example, negative 6x squared y. Here's my other x squared y term. So that's where I'm getting the negative 31 from. And then if I look at my xy squareds, negative 12 plus 5, that's where I'm getting my negative 7. Here's my final answer. Last real long one. I'm going to work this out down here at the bottom just so I have enough room. Again, I'm going to pause so I can show you all my steps. There's the first one. There's the second one. And there's the last one. The only thing I have left to do now is combine like terms, which takes a minute to kind of sort through. So a to the third b, if I go through and find any that look like that, looks like those are my only 2. I can combine those. That's where I got my 5 at the top. A squared b, all right, I've actually caught a mistake here. That should have been squared. A squared b squared. I hope I didn't throw you off. So I've got negative 40, negative 6, and a positive 30. That's where I'm getting my negative 16 from. And then my last pieces are my a, b to the thirds. Those are right here. And then a, b to the third. That's where I'm getting negative 36, a, b to the third in my equation. So check that and make sure you didn't make any errors. Hopefully you actually had that right instead of the exponent error that I had. The last 2 on this page are just telling me to verify. All that means is you need to actually work out the multiplication problem and show that you get this answer. So I'm not even going to do that because it's telling you what the answer should be. So take a second to work that out if you haven't done so already, and just make sure you're verifying or proving that that is the answer. If you've worked it out and you can't find your error, come see me tomorrow and we'll talk about those 2 specifically. Okay, for the most part, we are done with all of the new stuff right here. This is just review. So on question 17, you just want to remember your motions. So inside is opposite right here. That's where I'm getting the left one. Outside is what we think it is, so that is down 4. The 3 in the front, remember we nod our head up and down, so that's going to mean I'm going in the vertical direction, and it is what I think it is, so it's going to be a stretch by 3. Now the other thing that I want you to note, and this is for question 18, is what do these things do? So a left 1, that's going to add to my x, because that's in the x direction. And it's not actually going to add, it's going to subtract. All right, down 4 is going to subtract from my y. Vertical, that's a y component. So vertical is going to affect my y, and when you stretch or compress, you're either going to multiply or divide. Stretch is going to tell me to multiply, because we want it to get bigger. So multiply my y by 3. Now this is something that I haven't really showed you before in this notation. I'm just showing it to you to see if it makes any more sense. So they want us to map these points and figure out where they're going to go. And what I like to do is write myself a general rule for what is supposed to be happening. So in my x coordinates, if I look back over here, right, if I look over here to the rules, I just wrote myself in green. For x, I'm going to be subtracting 1. So I'm going to write x minus 1. In my y, I have to do 2 things, subtract 4 and multiply 3. So I'm going to multiply first, 3 times y, minus 4. I don't know if that's going to make any sense to you, but watch what I do with that to get my new coordinates. All right, so negative 1, 1. Remember, this is x and y. So my new coordinate is going to be negative 1 minus 1. Remember, I'm plugging into my rule, so negative 2. For the other one, it's going to be negative. I'm plugging this in for my y. So 3 times negative 1 is negative 3, minus 4 is negative 7. I said it and wrote the wrong thing, negative 7. All right, let's do the same thing with 0, 0. So when you plug that in, if I plug 0 in, right here, 0 minus 1 is going to give me negative 1. If I plug 0 in at the top, 3 times 0, this is what I'm doing. 3 times 0 minus 4, that's negative 4. There's that ordered pair. Okay, one more time. I'm going to do 1, 1. I'll try to write it out this time to see if that makes any more sense to you. And you may need to just go back and rewatch this section. All right, now I'm going to plug in. My rule says to do 1 minus 1, so that's 0. And then 3 times 1 minus 4, that's negative 1. So my ordered pair here is 0, negative 1. And then you'll notice that I just took these points and plotted them on the graph. And it did what it was supposed to do. It moved left, down, and it stretched it vertically because these points now, these reference points are now further apart than they used to be. Okay. Circles and parabolas. There's some weird math things going on here, so take a second to just kind of follow what I'm doing if you aren't sure with the equation. The one I give you tomorrow hopefully will be a little bit easier. So the first thing I'm going to do is reorder all of this. So x squared minus 2x. I'm keeping y squared over here, even though it doesn't go with anything because it is squared. And then I'm going to move the 15 to the other side. Now I need to complete the square. X minus 1, right? I'm taking half. When you do that, make sure that you add 1 to the other side. The y doesn't have anything to go with it, so if you want to write it like this, y plus 0 or minus 0, you can do that just so it looks normal, quote unquote. All right, this is 16. So take a second to make sure you understood where I got that from. And now the center, like you can see, I got this center here of 1, 0. That's coming from these parentheses. It's opposite of what we think it is. The radius is coming right here. Remember, 16 is r squared. So if r squared equals 16, and we take the square root, then r is going to be 4. And so all I'm doing when I plot that, I'm plotting this center point right here, and then I'm counting 4 in every single direction, up, left, down, and right. Question 20, kind of similar as far as how to interpret what they're doing. I know that this is a parabola because there's only an x squared, not xy squared. They've already done some of this work for me, so I'm actually going to write this just a little bit better. I think you all like it to be in parentheses. I think it might be a little easier to see, so I'm going to write this as 4 times y plus 0 because you're not adding anything to y there. You just notice there's nothing with the y, so it's got to be plus 0. Then x plus 1 squared. So the vertex, just like the center, comes from these two parentheses, and it's the opposite. X, -1, y is 0. So on my graph, the next thing I did with that was I took my vertex and I plotted it on my graph here. There's my vertex. Then I have to think to myself, how is this opening? I cannot answer these until the very last step. So I'm going to go back and look at my equation, looking right here at my equation, and thinking to myself, how does it open? Because it's x squared, I know that that means it either has to open up or open down. If I look at the 4 in the front, that 4 is positive, which means I need for my graph to be opening up. So that's why I know that this is going to open up. Then the last step, I know this feels like a lot to remember. Hopefully if we keep like looking at it every once in a while, it won't be so bad. The last step is this is 4p. So if 4p equals 4, then p is just going to equal 1. So all I'm doing there is I know that my graph is supposed to go up. So from that point, I went ahead and drew this. And then I'm just counting 1. I counted 1 up to find my focus, and then I'm just naming that ordered pair, and then counting down to find my directrix, which is this line right here. So that's where I'm getting these last two pieces of information over here, the focus and the directrix. Okay, woohoo, this is the last page. Question 21 is asking you to write an equation. It's asking for the total number. So f of x is full-time, p of x is part-time. So to figure out the total number, we just need to add those together. So that's all I'm just telling myself right here that we're adding. You don't even have to write that step. You just need to know that you're adding. So all I did was combine like terms. Hopefully I did not make an error. 22 is asking for us to figure out the total number in 2016. So I'm going to use my equation right here, and all I have to think about is what do I use for x? Well, if the starting year is 1970, and now I want to know about 2016, if I subtract those, that's going to tell me I need to use an x value of 46. So all I did was plug 46 into this equation, into every spot that has an x, and it gave me this number, 1,159,617.5. Obviously, you can't have half the student, but that's why it says this is an estimation. Okay, please, 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 please come to tutoring tomorrow if you need help with more than just like one question. My goal is that when you all come in tomorrow, we can just start on whiteboards, work out any example problems that you want me to, not specific ones on this test, but for example, if you want me to work out another question like 17 or 5 or whatever number, that's what you need to come in and tell me tomorrow so that we can practice and then get your tests going and be ready to do well. So hope this helped.